I'm Anil Kumar, and here is a very interesting question on even and odd functions. The question is, can a function be both even and odd? Provide an example to support your answer. So let's think about it, right? So let's explore. Let us say the function is even. Let's consider first that the function is even. Okay. In that case, let's say if I have a point here, then I should have corresponding point here also, right? So if I have a here, then even means you are going to reflect it on the y-axis, correct? So this is y-axis, this is x-axis. So you're going to reflect it on the y-axis. So you'll have a point here, which I'll say a dash, right? If I have a point here, then we should have it here also. So if this is b, then I have b dash here, correct? So let's take for the time being just 2 points. Now, if I create odd function, let's say this is also an odd function, let's say this is also an odd function, in that case, what happens to these points? Now, in this point will be kind of same, but here, this point can get reflected about the origin, right? This point gets reflected about the origin. So what do you get? So you get a point which is b dash, same distance away. Okay, let's give us points as, let's say this point is 1, 0. Then this is going to be minus 1, 0. And let's take this point as 3, 4. And let's take this point will be minus 3 and 4, correct? Now if I reflect this point about the origin, and let's say if it is an odd function, then what happens? Then that means at 3 I'll have a value minus 4, right? So at 3, which is here, I will have a value which is minus 4. So I get a point which is 3 minus 4. Do you see that? Reflecting it about the origin gives me a point 3 minus 4. As soon as I write this point 3 minus 4, it fails the vertical line test. Do you see that vertical line test? So that means on this line at x equals to 3, I have two y values. So it is no more a function. Do you see that? So it is no more a function. So I cannot reflect the same point on the x-axis, and also, you know, once you do that, then reflecting about the origin brings it back with the same x value. Do you see that? Minus x, minus of minus x is plus x. So for same value of x, you get two different values of y. So it is no more a function, right? It is no more a function. So we conclude that most of the time, function cannot have. Now I'm writing most of the time, right? So that means there must be some time when we could have, right? Think about it, right? Take some time to think about it. Let me complete this statement. Most of the time, function cannot have both even and odd symmetry. Sometimes it is possible. Think about a function which has just one point. For example, I have a point at origin, and now I define my function, and my function over here is f of x is equal to just this point 0, 0, right? So just this point 0, 0. Now this is symmetric about y-axis, it is even function, it is also symmetric about the origin, right? So that function is a function which is both even and odd, right? So this function is both even and odd. Do you see that? So this function is both even and odd, and therefore that becomes an exception, right? So that is one way we can find even and odd functions, right? Is there any other function which you can write which is both even and odd? Now take a clue from this and write down your answers. So I'll leave that for you. You can always post your answers in this video and I'll check on them. And let us see who gets it. Thank you and all the best.